A very good morning to one and all. On behalf of the entire alumni team of DBIT, I welcome you all. I'm Crisel Fernandez, the alumni coordinator of DBIT and one of your hosts for this event. If you have any questions during this session, please feel free to put them in the YouTube chat box or in the WhatsApp group. We will be taking care of your questions at the end of the session in the Q&A round. Cloud computing is gaining popularity and is a rapidly increasing field. We at DBIT always like to keep ourselves updated with new technology. Who better than our own alumni to give us his insights on it? So welcoming Mr. Riven Jose, the alumnus of the 2011 batch Computers. He is currently a senior consultant at Deloitte India who specializes in designing and delivering cloud solutions in Azure. He is a certified cloud solutions architect. He has 9 years of work experience across Azure, SharePoint, MSPI, and UI development. Over to you, Mr. Riven.
Hey, thanks, Crystal, for the introduction. Hello, everyone. Good morning. I hope you can see me. So good morning to everyone attending in the Zoom as well as YouTube. So I'm Riven. Today I will give you an insight into cloud computing, and I'll try to focus more on the real life scenario where it is used so that you will have a better understanding of cloud computing, if not the exact one. So what I'll do is I'll take the session in 2 or 3 parts. First would be a basic, there's a PPT, a bit bookish, wherein I'll go through those slides and explain the basic tenets or concepts of cloud computing. And then I will try to show a few demos wherein you will actually see how this maps, or when I say infra as a service, what that actually means and how it is used. So a demo, I'll take 2 demos, one for infra as service, another for platform as service. And then we can just go through other areas or avenues of cloud computing. And then you can start with your questions. I'll try to answer those. So let me start sharing my screen. Let me know if you can see the PPT.
Yes.
All right. So today we'll start with cloud computing. So anyone, you attending from the Zoom meeting, can you tell me what is your understanding of cloud or cloud computing? Just a basic definition that you know.
Something that does not involve hardware part and everything
Yes.
is online.
Correct. It's correct to a large extent. Yes. It doesn't involve any hardware and it happens online, not on your remote system. Correct. So I'll just go with the first question. What is cloud? So this is a bit of bookish or traditional definition. So cloud refers to anything that you access over a remote network or internet. So using this definition, even any website you browse, right, like DBIT website, it's also cloud, which is technically true. However, in today's world, when you say cloud computing as a word, it is much more than this. So let me give you an example. If you have hosted a website, let's say with Google or with some providers such as GoDaddy.com, that is technically a cloud. Even if, let's say, you have hosted a website in a DBIT server, which is not in public internet, but let's say I have connected to your DBIT network and I'm able to access it from my home, that is also considered as a cloud, and it would be a private cloud. So anything that is accessible remotely, any service that you can access remotely via internet or a private network without consuming your own resources, let's say apart from your web browser, would be traditionally or by definition technically considered as a cloud. Next is cloud computing. So we have an understanding what a cloud is. It has to be some kind of service that is delivered via internet prominently. When it comes to cloud computing, and this cloud computing, I'm referring to all the services that is provided by providers like, let's say, Azure, Microsoft Azure, Amazon's AWS. Google has their own called as GCP, Google Cloud Platform. Similarly, there are other firms as well. There's Alibaba Cloud, there is Tencent Cloud, and there are, I think, Oracle Cloud. So these all are traditionally called as cloud service providers. Those are the big guns of cloud computing. So what a cloud computing involves is they should deliver you computing services. When I say computing services, it is not just restricted to storage, because Google Cloud is a cloud solution. wherein you store your files, photos, etc. in cloud. That is actually cloud, and it is stored in Google Cloud Platform. That is just a storage part. Now, let's say you need to use databases. So today, how you do databases, you will have the database or SQL Server installed on your system, on your desktop or your laptop. In this case, these databases themselves are deployed on servers that is managed by these cloud service providers like Microsoft or Amazon. So you are not required to install software for running your database. There is no need of services that you need to install to maintain and configure these databases. So this service is now provided via internet, not directly on your system. Similarly, you might need a software which you need to use without installing on your system. Take an example, you have huge volumes of images that you have stored in, let's say, GCP or Google Drive, and you need to run some kind of facial recognition or image processing on that. In that case, these cloud providers have their own APIs or solutions which cater to that. Now they will take the image from the storage, online storage, and then they will perform the image processing on their servers, and then they give you the result. So nothing is happening on your end. It's all happening on the CSP or the cloud service provider end. So basically, this is how you know cloud computing works. Nothing is happening at your end. Everything is taken care by the cloud service provider. So here you can see there are servers, storage, databases, networking. Now, when I say networking, imagine you have your DBIT network. There's a local area network, right? With lots of computers. There's a hardware lab, there's a software lab, then there's library. All of this is controlled by a server room and you form a DBIT network. Now, when I say cloud computing, all of this would be replicated into a cloud service provider. You will have the exact same functionalities. Instead of going and sitting in your hardware lab, accessing a computer or a desktop, you can log into a computer from your system. Now, I remember we used to have this evaluation. I don't remember the name, a portal that we used to use in DBIT. So usually what we used to do is go to hardware lab and give the exams, right? Now, cloud, and the networking is taken care again by the cloud service provider. You don't have to set up server rack, create compute, have wires running around, join computers. All that would be taken care by CSP. Next is software. So you have, right, wherein you can use spreadsheets without downloading or using Excel. You can do everything on cloud or online. That is also software itself. So if cloud computing is the current frontier, analytics and intelligence, that is IoT, is the next frontier in cloud, wherein you get gigabytes of data or even terabytes of data, and all of this needs to be processed, analyzed, and then you have to perform machine learning to find results. So all this now happens on cloud. There is no need when I say economy. Let's say today you have a streaming website. Let's say DBIT has got a streaming website. Now next we can Canadilla or Sundar Pichai. So you know that there'll be a large turnout. Let's say if usual turnout is 20 or 25, on that day there could be thousands of them, thousands of you joining the seminar. In that case, your existing network might not be able to support that load. The bandwidth wouldn't of your VMs, your RAM, and your storage. And then just for that one day, you can scale up and you just pay for that day. So you don't need to go to the market and buy new RAM, new hard disk. Just for a day, you can scale it up. So that is the economy of scale and flexibility. And then there are a few, yeah, as I mentioned, pay only for the cloud service you use. So today in your hardware lab, you might have 20 computers. You might not need all of them. So however you have paid for them, You have to make an upfront investment for 20 computers, and they might not be used for 20 computers, but you buy it. Whereas in cloud, you can go with whatever you need. If you need 10 today, just pay for 10. You need 100, you pay for 100, and for that amount of time. It's not that you pay for a computer itself. You just pay for the usage. That usage time that you borrow it, that's what you pay for. So that is how cloud computing works in a real life scenario. So I will give you few more scenarios or use cases where it you can look at it happening in your life itself. Okay. Next, let's go to the benefits of cloud computing. So first benefit is obviously the cost. You don't need to invest for your own server rack, computers, processors, nothing. Even softwares you don't have to buy. So let's say in case of your college, DBIT, you have 10 computers. If you are using licensed versions of Windows, you need to buy 10 licenses, which is again upfront cost. Whereas in cloud, you don't need to pay for all these separately. Everything would be included in a total bill. Let's say you need for 10 hours, you will be charged, let's say $50. That's the cost of everything. You don't need to pay granular for hardware, RAM separately. No, everything is covered, and it is more cost effective compared to buying your own infra. Next is speed. So as I mentioned, right, for an event which requires more bandwidth, you need to acquire resources. That is hardware as software, and it takes a time. So you can't get it. Let's say if you want it in 2 hours, you won't get it. Neither you can set it up. Whereas in cloud, if you want to scale up to next level, it will just happen in few minutes. That's the speed part of it. Quick deployment and quick ramp up. Scale. So during our days when we had a small chapter on cloud computing, we always used to have a confusion between what is scalability. So scalability is not just scaling or increasing the number of RAM you or amount of RAM you have or the hard disk you have. It also depends where your resources are provisioned in. Let's say we are in India, but now we have customers in US. So you might not want them to always come and use your server. Let's say if they log in, you don't want them to always get redirected to a server in India. So what you can do is you can replicate whatever you have in a server in US or a data center in US. That is what actually term scalability means. Apart from scaling your hardware, you need to provide availability in specific regions. Tomorrow, let's say Europeans want to use your system. That time you need to have servers in those areas. That is the scalability part of cloud computing, which we cannot match individually unless we have lots of money to have a server for DBIT in Europe or have it in US. So this is a very major advantage, which let's say in my project or for our clients we used on a day-to-day basis, because they have customers from all parts of the world, so they might need to scale up at a particular region for a particular day. So that's how it works. Next is productivity. Now productivity comes mainly from the manual part of it, wherein traditionally you need to have engineers, network engineers, who would go set up your hardware and configure those to run, which takes a huge amount of time. So I remember when they used to provision an on-premises environment for a client, it used to take a week, minimum 2 weeks, not even a week, 2 weeks. They give you 2 weeks SLA that they would require 2 weeks to set up the bare minimum for us to get started deploying the software or the solution. So that from 2 weeks, now it has gone to less than 2 hours, even less than that. Depending upon how good you have created your solution, you can deploy it within 2 hours. So that is the productivity part. It saves hours. And in IT or software industry, everything is built according to hours. Each and every person working, they have resource hours. So if I'm working on a project, they will bill me $80 per hour. So for 2 weeks, it's a huge amount, right? Whereas in 2 hours, I'm completing the task. So it's a savings for client. That's how they look at it. Performance, yes, of course, performance. So when you to an on-premises or local deployments, you need to know which processor to buy. Let's say you need to buy a dual core processor, a Xenon processor. You have to think of all these things and the permutation combination, whether this would work with this or not. Here, you are guaranteed performance. You can just keep on scaling up to whatever GB they support. Let's say 128 GB, 256 GB. You can go up to that easily. You don't need to again think of performance. You can scale up to very huge degree of scalability. Reliability. Now, reliability comes from the point, let's say there's a power cut or some kind of network outage in these DBIT servers, then everything you have goes down. DBIT.com would or DBIT.in would go down. There's no way you can recover quickly. Whereas in cloud computing, if you have a primary data center or primary location where you have your website or your software running, you can have a backup location or a secondary location wherein you have backups and the replicas. In case one data center goes down, which happens rarely, because these cloud service providers like Microsoft or Amazon, they give you 99.99% SLA. That means there's 1 in a million chance that their data centers would go down. Even in that case also, you are covered. Immediately it will switch to the secondary data center. So as a customer, you will never face any issue. You won't even notice the downtime. Rarely you would notice unless there is an outage of a day or so, or let's say it affects multiple data centers. Reliability is top notch. Now come to security. Now main concern with all your traditional clients is security. Let's take an example of a banking client, and especially the banking and insurance clients are very reluctant to move to cloud. They are the last bunch of folks who are migrating to cloud because they have this concept that cloud is not safe, which was correct, let's say 6 years ago. But now cloud is more safer than your on premises because you have your Windows Defender and Windows Firewall for your local systems. You have all those in cloud as well. And those are the basic securities. You have cloud specific security solutions, which are way better than anything you would have on your local system. These are AI based solutions wherein it learns, keeps learning. Let's say there is a new vulnerability. You don't have to download the patch for that, or your Kaspersky might not need to keep on updating. All these are done automatically by your cloud service provider. So that is one level of security. Next level, what you can do is for your own systems or your own VMs or computers on cloud, what you can do is you can have additional layer of security. You could have IP based filtering. You can see that only users belonging to this particular IP addresses should be able to access your system. That is one layer of security. Then you can have multiple layers of custom policies, which can see that if a person is uh, accessing your website from a, let's say, mobile device, and that mobile device is an Android operating system, and you need to block Android users, you can do that. You need to block some other third party OS apart from, let's say, iOS or Android, you can do that. So you get multiple layers of security, which is very difficult to implement on a traditional system without having a huge downtime. So if I were to implement the same thing, let's say blocking a particular device or a OS, I need to again go and code in something in my, let's say, solution and deploy it again. Whereas in cloud, you don't need to touch your code. You can just create securities on top of your solutions and then block things. So even before reaching your website, right, you can create multiple layers of abstractions and security. So this gives you a better security posture. These are the reasons why today most of the banking clients have moved, you can say 90% of their data to cloud. Maybe 10% remains, which I don't think they will be doing that because they're very protective of data. So they will keep on premises. So again, this on-premise data is accessed over cloud. I'll come to that, how that happens in the further slides. So these were the few benefits of cloud computing. Okay, next, types of cloud computing. Now there's certain confusion in people. What are the types of cloud computings? So I've divided these into twos. One is deployment type. That is the actual kind of cloud that you're using. And the second is types of cloud services that you consume. So let me go by this, types of cloud computing. Deployment types. Now what deployment type?
Sorry to interrupt you.
Yep.
There's a black panel appearing on this right hand side.
Oh, sorry, I'll just
Yeah.
minimize this. Yeah. Is it gone?
Yes, thank you.
Yeah. All right. So let's move to the types of cloud computing. This is deployment types. Now, deployment types, when I say deployment type, it is the actual cloud infrastructure or cloud architecture that has been followed. So we have three types. One is public cloud, private cloud, and hybrid cloud. Now, public cloud is simple to understand. It is your traditional cloud service providers like Azure, AWS, GCP, Tencent, whatever. So these are public cloud because you as a customer, now let's say DBIT wants to go cloud. So you can go to any of these cloud service providers and tell them that I want a cloud subscription or a cloud account. Give me that. So you will pay some money, you will have a agreement with these service providers, and they will provide you a account, a cloud account. That is public cloud. Very simple. This is what most of you would use, or most of the clients would use. Now comes the next part, private cloud. Now there are organizations which are, they are never going to go with public cloud. They don't want their data to be outside of their data centers. So let's consider a huge organization like Facebook. They wouldn't want to host their data in AWS, Azure, or GCP. They want total control of everything. Yet they want to make sure that they are also using this cloud nomenclature or cloud architecture. So they will create their own cloud infrastructure. So whatever these guys perform, right, in terms of infra or services, they will replicate that for themselves, and they have vast amount of wealth, so they can afford that. So Facebook will have their own data centers that would, match these guys for all intents and purposes. That would be as good as this. However, whatever they have over here would be private to their employees, their developers, or their teams. We as an end user will never be able to access a Facebook cloud. Only thing you could access is the Facebook website or an Instagram, that's it, or WhatsApp. Apart from that, you can't go ask them for an account in Facebook cloud. No. So this becomes a private cloud. Technically, DBIT servers can be counted as a private cloud because you would have your hard disk where you store data, right? So loosely you can call it as a private cloud. However, to be a proper full-fledged private cloud, you need to have certain criteria, meet certain criteria, like have a data center. You should have a few layers of security, and you have to follow certain points, best practice or architectures of a traditional cloud computing. So that is private cloud. Now hybrid cloud. Now hybrid cloud is something I mentioned, right? Banking customers won't go totally cloud, 100% cloud. That's where hybrid cloud comes into picture, wherein they will have certain parts of their infrastructure on premises in their data centers, and they will connect to a public cloud or a private cloud. So usually it is a combination of a private cloud and a public cloud, or an on-premises network of the client and the public cloud, wherein if you work for, let's say, Bank of America, they would have a cloud account, cloud subscription, where you log in, and there you can use the networks or the computers on your on-premises as if it's your local systems. You won't understand the difference between a computer that is present on their own premise data center and that is hosted in the Azure or AWS. So it works seamlessly. However, for the separation of concerns, your conferential servers will always be on the private portion of that or on the on premises. So that forms the hybrid cloud. So these are the three deployment types. Now there is a fourth one, which, or rather there's a fifth one as well, which is a subset of these. They are not individually, can't be called as a deployment type. One is called as a community cloud. Usually community cloud comes when you have a open source cloud wherein you will have a bunch of people who are contributing towards the upkeep of it, and then it is free. It would be usually free. You can contribute and you can use it. You will get all the facilities of a cloud computing, but at a smaller scale, and it would be free, relatively free. And the fifth one is government cloud. Now, government cloud usually is offered by these guys. Azure has something called as Azure Gov. AWS would have AWS Government Cloud. So this will have slightly more restriction compared to a normal cloud account. And these are used by government organizations. And if you look into European countries or China, they have their own data security rules. In Europe, we call as GDPR, data protection rules. So you can't offer them this part of Azure. You will have to give them something tailored to their geography, wherein you will make sure that you can't deploy anything outside of European data centers. So if the client is a German client, there is no way they will have anything running in a US or an Indian server, Indian data center. So that's a government cloud. However, by and large, these are the three you need to understand: public, private, and hybrid cloud. Next differentiation comes in types of cloud services that is provided. And I think this is the one you guys might have learned: infra as a cloud, infra as a service, platform as a service, and software as a service. So I'll just quickly go through this. So in the beginning, I asked you, right, what is cloud or what is cloud computing? So the answer was You don't need to worry about computer. You can have it in cloud. So intra as a service, you will still get the choice to select which VM to run, which virtual machine. When I say virtual machine, think of it as a computer or as a machine. So which VM to run, which OS to run on it, how much the RAM you should have, the type of hard disk you use, whether it's a normal hard disk or as SSD, and then how much memory, how much disk space, you still get a choice on that. And here you always get the independence to create your own network. So similar to the term virtual machine, you have something called as a virtual network. Virtual network is used in Azure. A similar nomenclature is virtual private network in AWS and GCP. That is nothing but imagine your network, imagine your DBIT network, you have replicated into cloud, it becomes a virtual network. So you don't know where you don't have access to physical servers or physical, let's say, network interface cards or RAM. It's all replicated in cloud. So your virtual networks, virtual machines, if you provision all these things by yourself, it is called as infrastructure as a service. I'll show you an example of this in our demo. For now, think of this as you going to a cloud service provider. However, you will still create your own VM and your network, and then you will remote into that and deploy your software. So this is what you mean by an infrastructure as a service. You have some control or a greater control on your VMs, etc. And then again, since this is a cloud service, you pay on a pay as you go basis. That means if your VM is running for 10 hours, you just pay for those 10 hours. You don't pay separately for the VM OS license or for a RAM and all. Everything you'll get a total bill saying that for 10 hours you pay, let's say $50. And when you shut down the VM, most of the things would be deallocated and then you don't pay for it. There'll be slight payment you have to make because you are still reserving an IP address or a network interface card if you go for a static IP, because you need to remote into the VM, right? So you need an IP address or a URL, so you pay for that. If you don't even want that, you can let go of that as well. So essentially, what happens when you shut down a VM is that it gets deallocated. The RAM that was allocated to you, it goes away. It will now get allocated to some other user. So these all are shared resources. So that is infra as a service. Next, we go to platform as service. Now, in this platform as service is more towards developers. So in this case, let's say I'm a developer, I'm creating a website or a program, and I need to make it available to the internet or to the world. And I don't want to be bothered about the type of VM I should use or the type of amount of RAM I need. In that case, everything is taken care by the cloud service provider. Usually what I do is I'll get done with my development and then I deploy my entire code or file to the cloud in something called as an app service. App service is a term that is used in Azure. You have similar terms in AWS. App service, imagine it's a container where you publish your code and then it becomes available to the internet. So in this case, there is no VM deployment, no headache of infrastructure deployment. I just need to create my code and deploy it, and it becomes available to you instantly. That is platform as service. Next is software as service. Now, this is the easiest one, or you can say the most comfortable one, wherein you are not even creating a software. Even the software is available to you. So examples of this would be Facebook, I wouldn't say, but let's say you want to crop an image or you downsize the size of an image. You would upload it to a website and it will shrink your image, right? Now that service is a SaaS, software as a service. Similarly, your Google Sheets or Google Docs is a software as a service, wherein you are not even installing a software to perform your operations. It's all provided as a service. So that is software as a service. Now these three are the traditional ones that you might have learned. Now there's one more, which is an extension of PaaS, platform as a service. It is called as serverless computing. Now the word is serverless. However, in the backend there is server. Now what is the difference between serverless and PaaS is that in PaaS, you still need to choose an app service plan, a plan wherein you would say, okay, minimum, I need let's say 2 GB of RAM. At any point of time, I need at least 2 GB of RAM. And let's say I need 1 GB of space minimum. So now in that case, unless I have some scale up rules or a rule setup, scaling rule setup, if the demand increases, let's say there's a huge load on my website. So this 1 or 2 GB that I have, the plan that I've chosen, right, it won't be able to cater to that. At that point, unless I have automated scaling rules applicable, my website will go down. It will be kind of a DDoS attack wherein it won't be serviced. That website will start going inaccessible to many people because it has hit the threshold of the service plan I've taken. Consider this: you have a 2 GB data plan on your phone, you exhaust 2 GB, you can't use the internet. As simple as that. Similarly, PaaS is how it works. Now, let's say you don't know how much would be the demand for your app or the service that you have written, but you know that whenever there's a high demand, you need to make sure that it's highly available. In that case, you go with serverless computing, wherein you just deploy your code and then your cloud service provider takes care of the rest, wherein they have something called as a consumption plan. So they know, they will monitor how much traffic is coming into your application or your website. According to that, they will auto scale. And here the best part is you just pay for the right down to the seconds. Let's say your website is up for 10 minutes 5 seconds, you pay for that amount of time. It's that low. And after that, if let's say no one is using your service or website, you don't pay anything unless it's being accessed. There is no charge on that. Whereas in terms of PaaS, right, if I take a plan, right, app service plan of 2 GB and I paid $50, regardless of it gets used or not, I have to pay $50. Again, similar to the, let's say, the prepaid plans we have, right, wherein if I go for a 100 rupee plan, whether I use it or not, I have to pay 100 rupees upfront. So that's the difference between PaaS and serverless. And serverless is quite popular because it's even faster than PaaS. So it's usually used for, you can say, small functions. It's not used for full-fledged applications. If you have a long-running full-fledged applications wherein you have lots of processings to be done, you would still go with PaaS, because serverless computing just supports simple functions. There's a concept of functions and Lambda. Lambda functions in AWS, in Azure, we call it as Azure functions. So these are small bits of code. It would just run for 5 minutes. So this is more useful if your runtime is low, but it might be used frequently. So that's where you use serverless. And it is good for you guys to even, look into these things, because these are very hot topics and high demand in the market as well. So these are the types of cloud services. So officially the PPT is done. The lecture part of it is done. So if anyone has any questions till now, they can ask, and then we can continue with the demo. Let me know if you want me to go back to any previous slides and explain any concept again. Okay, I hope all of you are awake. No one has gone to sleep, because I know how this PPTs tend to.
Yes, sir, you can go ahead with your demo.
Yes. So before going to demo, just to illustrate, I got an interesting image about how you distinguish between these infra service, PaaS and SaaS. So this is an example quite popularly used, pizza as a service, wherein this is what normally traditional on-premises is, non-cloud system, wherein you need everything. So this is making a pizza from scratch. You need everything. You need to have the infra, you need to have the software that is the topping, and even the fire, everything. Now, when it goes to infra as a service, think of it as ready to make or ready to bake pizza, wherein you should have a stove or a basic necessity at your place, a dining table, etc. And then you can come and cook it. So the cloud service provider would provide you this. This is infra. Next is PaaS, wherein you just need to bother about a place to sit and eat and maybe have a soda. Rest everything, it's home delivered. So this is your Swiggy kind of thing, wherein everything is delivered, you need minimal effort. And this is your SaaS, wherein you're going out to have pizza, where you don't need to care about anything. You just pay for it, you get everything. So this is an analogy where you can compare how it works. And serverless, you can just compare this. It's the same thing, but on a much higher level and easier one. All right. So now moving on to the demo, I'll show you how an Azure platform looks like. So I have access to an Azure cloud platform. So we were talking about cloud computing, right? So you need to have a console to manage things. So this is Microsoft Azure. So, so I, as an developer or a architect, have access to a subscription, what we call as an Azure account or a subscription. So I'll tell you the concept of subscription. So this is called as account in AWS and GCP. Subscription is nothing but, let's say you have DBIT, we have various streams, right? We have computers, comms, IT, EXTC, MEC, right? Now each of you want to have something running on cloud, but you don't need to share the tenancy with each other. You want to isolate whatever you have in a separate boxes. So in that case, you can have subscriptions. Comms can have one, EXTC can have other subscription. So the subscription is nothing but a separation of concern again. And this is all virtual. There is nothing. So it doesn't mean that if you have different subscriptions in the backend, Azure might provision a VM for you on the same data center or even the same server rack. We have no visibility into that. However, for you, there is a separation. Visually, you have a separation. So that is subscription. Now, let me show you an example of infra as a service. I'll create a virtual machine. So now the virtual machine is nothing but they will provision a space for you. They will provision a VM for you. They will imagine this as a VM you create in a VMware or any a VM box. That's the same thing they do. They will allocate certain amount of RAM, of OS, and some disk space to you, and the related infra on a huge server rack. They will just provide you that. So now let's try creating that. So let me add a new virtual machine. So now this remember this is infra as a service. So I still have to do some configuration. Now this is subscription. So I take my dev subscription, then resource group. Now resource group is a collection. It's a virtual collection wherein all the resources you provision, if you want to club them together, let's say you have a VM, you have a VNet, you have some storage space, you have an IP address, and you need to keep it in one place, single, you can say container, that is a resource group. So let me also create a new resource group. So I'll create it as, let's say, okay, I'll do one thing. I'll create it separately so I can show you what is the meaning of a region as well. So I'll add a resource group. Let's say DBIT webinar. Okay. Now you see this option, right? Region. So if I hover on this info bar, it says choose a Azure region that is right for you and your customers. So this is very important. So if your intended customers are in US, so you need to find a data center or a region that is in US. So all the resources that is going to get created or deployed would be deployed over there. So it in turns improves the performance and latency. So there'll be no lag if you deploy there. Let's say instead of US, if you deploy let's say in Central India, South India, West India, that is not correct. So you need to decide upon where to deploy. Now in our case, let's say I'll take West India and I'll create one. So now a resource group is created. Now let's go and create a virtual machine. Now all this resource group I created, right? Don't consider it as IaaS. That has got nothing to do with provisioning any actual resources. It is just a container that we have created. That's it. Now creating a VM, right? It is in fact an infra as a service. Now I'll go here. It says resource group. So I'll select DBIT webinar that we just created. So by default, it changes the region to West India. Now I can create a VM. Let's say I'll name it as DBIT VM. This name can be anything. It's not globally unique. It's just restricted to my subscription. Now, if you come here, let's ignore these things. These are higher concepts. So there's an option called as image, right? Image is where you can choose the OS that you want. So these are the frequently used or highly used ones. If you need more, right, you can click here, browse all public and private images. You'll get almost everything you want. Maybe not the Mac OS, but you will get all the traditional OSs that you would need. So let me select a Windows Server 2019. So I've selected my OS. I'll ignore this. Now size. It asks me what size of the VM do you want. It says 2 CPUs and 8 GB. I can go for that. There's an option for 4 CPUs, 16 GB. Now let's see if you want even more, you can do a select see all sizes. So I can sort it by RAM. So this is 32 GB is the max that I can access for my, this is a developer subscription. It's not a full-fledged enterprise subscription. Otherwise you would get even more than this. Okay. So 32 is the max. So I can select from here as well. So now let me select 4 CPUs and 16 GB RAM. And it will have disks as well. So it will come with 8 data disks. And temp storage is nothing but the storage that gets created each and every time you start a VM. So this is not your disk, hard disk where you can store your files. Rather, this is your usually used for your OS and all. So I select this. Now it asks me for a username. So let me give my name. I'll give some password. Okay. All right. I'll need a slightly longer one. I hope that you guys are able to see this, right? Is there any lag? Then let me know. I can go slow. Is there a lag?
I guess.
Okay. All right. Now I'll keep these settings because I would like to remote into this VM and show you guys how it looks. Now it says, would you like to use an existing Windows Server license? If you already have your own, you can say yes, and then you can use this option so that you can even save up some more money if you have your own license. Otherwise, say no. Now next, you can go to disks. So you can select what kind of disk you want. Standard, premium, or SSD or HDD. So let's say premium is, I'll keep standard HDD since this is just for a demo. Now you can also use encryption types. I'm not going with any encryption, disk encryption now. And now if you notice, this is just the OS disk. Now you can go ahead and if you want to create more disk. So this particular image that we selected supports 8 data disks. So I can create and attach 8 data disks. So data disk is for data storage. So let's say I can select this 1 TB. I'll do an OK. So it's attached. I can create 7 more like this because these are the supports. So now I go to networking. Now, networking is the part where I mentioned, right? We have to create virtual networks. So your VMs will always reside inside a virtual network. Your network needs a backbone. So that virtual network is the backbone wherein you have allocated IP addresses to which your VMs get allocated. You can say binded to, or you can say get placed to a certain IP. So now here, I'll just go with the default VNet. So this, there'll be VNet that will get created called as DBIT webinar-VNet. Default subnet IP address, let it be default, and then I'll keep all basic. Now these are options which accelerated networking is, again, if you want a higher bandwidth support between your VMs and all, you can go for this. We can switch it off because we know we are not going to use that. Next is management. So management, again, they will ask you if you need boot diagnostics or not, if you want OS diagnostics. So if you switch it on, then you will have to provision a storage account. So all your logs will go to this account. So I'll keep these off, and then I'll keep auto shutdown as on. Okay. So these are the basic things you do when you do an infra as a service. Now I'll just skip all these and just review and create this. Okay. Meanwhile, that happens, I'll in parallel start with an example for platform as service. So what I've done is I've downloaded a demo website. I'll show you how it looks. It's a basic one. So now I'm running it from my local. So it will use my local IS server, and then it will open up. So I'll show you how it looks. And then what we'll do is we'll deploy this into cloud. And once I deploy it to cloud, you guys can even access that from your phones or your computer. So this is the PaaS capability wherein I mentioned, right? You can do a deployment within 2 minutes. You can go live in 2 minutes. So that's the example which we'll be using. So meanwhile, okay, it's taking some time. Okay. So yeah, this is the website. So it's a basic thing. There's nothing much. I've just edited a bit. That's it. There's nothing fancy over here. So it is running from my local now, local host. So now we need to deploy this to cloud. So we'll see how that can be done. So for that, we need to create an app service. So now what we are going to do won't involve a VM. It will be purely, we'll create an app service, which is where we will host our website. So I'll go here to app services. I'll do an add. Again, this will ask for a few basic information. So resource group. So what we'll do is we'll select the same resource group, the DBIT webinar one. So as I mentioned, this resource group is nothing but to group all the resources that you have together. That's it. That's the only intent. So the resource group is DBIT webinar. Let me name the website as DBIT web. Okay, it is available. So once we deploy our code, right, it will be available at https dbitweb.azurewebsite.net. Now it asks me whether it's a code or a Docker container. Now Docker is again another capability that's called as containerization. I'm not going into it because it's another topic for another webinar. So I'll select code. I'll just publish my code and I select my runtime as ASP.NET 4.7 because that is what I have written my code in. Now it asks for the region. So for our benefit, I'll keep it as West India. Okay. Now here, if you notice, I'm not selecting the RAM and all directly. There is no RAM selection or a space selection. What happens over here is when I come here, it says Windows plan or an app service plan. This is that prepaid plan I was mentioning, wherein I can select the prepaid plan. No matter how much I use, I will get this much. So I can show you other plans as well. So by default, it selects this S1 plan. So what it entails is 100 ACU. Now ACU is something called as Azure Compute Unit. You can think of it as your CPU utilization. It gives you some resources which you can utilize for running your website or your process. It's like CPU. So 100 ACUs and then 1.75 GB memory. So I can store up to this much data. If I have any data storage, I can store up to this much. And then it says, right, included hardware. So I'm not doing anything. I'm not creating the storage memory or selecting even the OS. I'm doing none of those. I'm just selecting a plan. That's it. Now I'll go ahead and create this in parallel. So I'll say no. Let me create. Okay, this is taking slightly longer time. I don't know what the issue is. Okay, let's try creating this. While that happens, let's try to create the VM. Pardon me if there is some network issue or I'll select. Okay, let it get created. So we'll go here. So the app service or the container that we created to store or host our website, right? It is done. So I'll do go to resource. Now, if I go to resource, you wouldn't understand much. It will say stop, restart, delete, etc. So if I want to stop my website, I just click this stop and it'll stop. It won't be accessible. So this app service is nothing like, let's say at your place, if you have a food processor, if you keep it on, it will keep crushing something. Similarly, the app service is a container or a dedicated storage and process, which will keep your code alive and available. So once you stop it, it just dies down. It gets relocated. Whatever memory is there, it gets deallocated. So when I say deallocated, imagine that in a particular server that is hosted by this cloud service provider, there is 32 GB. So I'm getting allocated 1.75 GB out of it. So similarly, let's say I'm getting 2 GB allocated from it. So there'll be 16 blocks of 2 GBs in that 32 GB. So once that is completely used up, And if I shut my app service down, that will be deallocated and that will be allocated to some other user or some other consumer. That's how it works. Everything is sharing based. Unless you go for a plan wherein you can choose an soft isolated hardware wherein you will get a dedicated space in their server which won't be shared with anyone. And of course it comes with a slightly higher cost. Okay, so our VM is getting deployed. Meanwhile, let me show you how this works. So you can see there's a URL, right? So if I click on this URL, it will take you to a standard IAS page. So this is this is how a standard IAS page looks. When you run or debug something, it will say IAS server running. So it's exactly the same. Your Apache server, right? Without any code, when you run it, it will open the browser in the local host. This is nothing but the same version of cloud. There is nothing here. Now, what we'll do is we'll try to deploy this over here. Okay. So for that, for a quick deployment, what I'll do is I'll take something called as a publish profile. I'll download it. I'll go to my code. Now, whatever I'm doing, right, it is this ID specific. So Visual Studio might do like this. You would have an Eclipse. It would have a different kind of publishing approach. And it all will work. So these cloud, right, it supports almost everything. So let's say if you want to directly publish from your code repository, such as GitHub, if you heard of GitHub, so you have something called as CI/CD, continuous integration and continuous deployment, wherein if I write a code, I'll deploy it into a GitHub or I'll integrate it into a GitHub, and then it will automatically go and integrate or deploy it into the app service. So I don't need to do this manual activity again and again. So for this demo, I'll use this approach wherein I'll go with publishing profile. Publish profile is nothing like, you share the contacts on your phone, right, via WhatsApp. Similarly, it is just a file which has shared the contact of that app service, which then I'll use to make a call to it or connect to it, connect my code to the app service. So I'll do a finish over here. So it will take some time. It will configure everything at the code end and then make sure that the connection is established. Let's see what our VM has reached at. Okay, so our VM is also created. So I'll click go to a resource. Now again, here you will see few similar controls: stop, restart, delete. So you can stop your VM. So now this is running and it's costing money. So whatever duration it runs, I get charged to my account. So now let me check this one. Okay, so our configuration is done. Now what I'll do is I'll publish this. So I'll click publish. Now this is as easy as it can get. So before our webinar started, I was explaining how, or the first demo I saw on cloud, that was this, wherein the trainer that was taking the session, he just deployed a website in whatever 2 minutes. That's it, and it was available on my phone. So this is the ease at which we can, go from production to live using cloud, which is not possible with your traditional systems. So now what is happening over here is whatever file structure I have here, right, it is getting deployed into the cloud. And notice here, I'm not concerned about the operating system that is being used over there, nor the amount of RAM. I'm just a developer, developed my code, my website, and just deploying it. So so this is published. It succeeded. Now let's go back to this URL. See, now it automatically opens that URL as well. So this is the URL this is how it looked when we created the app service, the website. There was nothing. And now look at this URL, and this URL is the same. And now we have our website up and running. So if you try browsing this URL from your systems, I'll just post it in chat window. Okay, don't I have access to chat? Okay. All right. So if you just type this out, dbitweb.azurewebsite.net in your browser, you will be able to access. Let me know if you're able to access this.
Yes, we are.
Yeah. So what I showed is just, you can say, not even the tip of the iceberg. This is very simple demo thing. In reality, the system, we deploy complicated systems, banking solutions wherein they need to have end-to-end service. It will involve multi-layered architecture. There will be a database layer, there will be a middleware layer, and there will be a front-end layer. Then you will have your, what you can say, firewall layer. So all those things can be done, let's say, even in a day's time. So usually you get a week or so even in cloud because you need to do sanity testing, other rounds of testing and all. But you saw, right, how easy it is to do this. So this is an example of how PaaS works. So now if you learn this in your courses, you will understand, okay, this is PaaS. Instead of going by the bookish definition, you have a picture or a context now. Now let's go back to our infra part. That is our VM. So now this VM is up and running. Now you might ask what to do of that. So now let's say I want to connect to it. What I'll do is I'll just download a RDP file. I don't even need an RDP file. What I can do is I can take this public IP address. So remember, URL or a public IP address is always your address on the internet. So I can change this to a URL. If I want to do it, I can do a domain mapping, give a domain and make it as a URL, which in turn hits this. So your URL, right, your dbit.in is always mapped to an IP or a load balancer. Anyhow it will be an IP that would be your reference. So it's like your room number or your flat number. You might live in a locality, but your flat number would be a distinct address, right? That's what the IP address is. So now I'll try to remote into this. Okay, so I'd used these credentials when I created this. So I entered my credentials. I do okay. I accept this. So it says to accept the certificate so that it's trusted. I do a yes. That's it. And I'm connected to a VM, which I don't know where it is, somewhere in some data center in West India. So this is the actual use of an infra. So now what is the use of creating VMs instead of using PaaS? Now you might ask when to go with a PaaS solution or an infra solution. Imagine a client who has got lots of legacy systems. They have their own softwares, their own plugins created, which they have deployed on their actual existing on-premise machines. And they need to make sure that tomorrow, if there is an update to a certain OS, now they need to make sure that if their software just runs on a particular OS and a particular version of an update, so then they go with IaaS, infra as a service, wherein they can control the update as well. So if you look at this VM, right, it's exactly the same that you would have seen in your labs. If you have seen a Windows server, it's exactly the same. It functions exactly the same. If I just hide this right ribbon, you wouldn't even know whether I'm remote or not. You would think, okay, this is my local machine. So here you can deploy your software and you can run your own server from here. So how you similar to how you run a web server from your local machines, similarly you can run a web server from here. So this is the example of infra as a service. Very basic example. Usually what happens, if I were to tell you in terms of architecture, there'll be a huge, okay, I'll show you a VNet, what a VNet is. I mentioned right there is a virtual network. So usually what happens is virtual network will have a range of address. If you see this address space, it is of the format 10.0.0.0/24. What it means is that my starting IP would be this, and I will have, I think, 512 IP addresses allocated. A few would be reserved by Azure, but after that, I will have this much amount of IP addresses, which I can use to either create a VM, host a service, anything. So this is how a VNet is. I'll try to show you a diagram. Okay, yeah. So if you were to visualize what we have done now, I'll show a diagram. If it loads quickly, it will show. Okay, so see, this is how the hierarchy looks like. This is that VNet I'm talking, right? This is the network. Inside that, there is a subnet. Now, subnet is, if you further subdivide a VNet, right, it is called as a subnet. Consider DBIT as a VNet. Hardware lab would be one subnet, software lab would be other subnet, library would be other subnet. So they would have their own set of rules, but they are still part of single network. And then this is a network interface card. So network interface card is nothing but your LAN card or your network card that you have in your VM. So as I mentioned, although this is a VM, this is actually a physical system that gets provisioned somewhere in the data center. So you have got this network interface card allocated, and then you have your actual VM, which includes your, let's say, your processor, your storage space, and OS, etc. And this is your IP address, the same IP address that we used to connect to the VM. So this is a basic diagram or topology of an infra as a service. Now, when it comes to real life scenario, I'll try to show an architecture. All right. Let me try to open this in a new tab. Okay. So if you look at it, ignore this on-premises network. Now, this is a good example of a hybrid cloud. This portion is Azure, and this is on-premises of a client. Ignore this connection, and also now, imagine this is a virtual network. In that you have multiple subnets. So this is one subnet, management subnet. Then there is a DMZ, demarketed zone. Usually, DMZ is to place your network virtual appliances, your firewalls and all. So this is how your production VNets look like or architecture looks like. And here you can say that it's again connected to other VNets. So these are some basic architectures, how in real world you use an infra as a service. All right, so that is infra as a service. Now, few things I would want you to see would be type of resources or services you have. So if you look over here, you have compute. So compute usually involves your storage, VMs, etc. And then if you want to create a database, so some of you might have installed a database, MySQL or IBM Rational Rows or something like that on your system, right? And then you would be using from your own on your local system. In cloud, you can create a managed instance or a SQL server, and you can create tables and access it just using your SQL Server Management Studio or whichever connector you have. So you will have your entire storage on cloud. That's it. So you don't need to even spend for that. Then there are advanced parts of this. These are Internet of Things. So IoT is what you imagine. You will have a fridge, you'll have an AC, you will have some other appliances. They all talk to a device, and that device will stream data into cloud, and then it will perform stream analytics. So again, it comes under AI and machine learning. So IoT is to get your data into cloud. So there are things like Event Grid, etc. So if you have it's a Raspberry Pi is one of those systems which can collect information. It's a sensor. You can join sensors to it. It will collect the data, and then you can pass it to cloud using IoT. And then you can use AI and machine learning to get more analytics or more data on that. So for example, you will get your usage pattern of your AC, at what timings you use AC. So it will learn, the machine learning will happen, and then make sure that automatically then it starts AC at, let's say, 10 p.m. when you're going to sleep. So all these things now happen in cloud. No one goes and creates their own infra. Another interesting thing is blockchain. All of it is in cloud now. And then there is something called as containers. This I'm not sure if you guys know of containers. So containers is, again, if I explain now, there you will be confused within containers, app services, etc. So maybe later we can go to containers. So containers is again another level of separation, wherein you don't, let's say you write your code in C#, that which is a, you can say Windows driven or Windows bias language. But using containers, you can run your code even on a Linux system, Linux or other OSs. So in containers, you are not even concerned about what kind of framework you use. So if you track back, I used ASP.NET framework. I did that selection, which means that that is the supported framework for my code. In terms of container, even you don't have to do that. You just deploy your code. So imagine this. You are not concerned about the kernel, OS, or the framework. Even that is taken care. That is containers. So yeah, these are the few major things I wanted to share with you. And software as a service, I don't need to show you an example. You might have already used. Even your Google Cloud and your Google Suite is a software as a service. All right. So I guess that was the demo for both PaaS and infra as service. Now, if you have any questions or any queries, you can start asking those.
Thank you, Mr. Riven, for those amazing insights and experiences. I'm Ruben Crasto. I'm the other alumni coordinator of DBIT. So without any further ado, let's start with the Q&A session. So we have our first question.
Yes.
What is necessary for a student to get a job in cloud computing, and cloud certifications or an experience in cloud? So like,
Okay. I was expecting this question. It's actually a great question. So let me tackle in this way. Now, most of you would be third year, fourth year, right? So you guys have time to actually form a base without joining an IT company, right? So leave the certification part. So what you need to start with is you need to understand what are the use case for cloud computing. So if you are a developer, understand that you will work in PaaS, platform as service, which is also called as cloud native development. So you need to start learning one language. At least you should know one programming language properly. And then instead of creating things locally, you need to start creating those for cloud. And when I say start making for cloud, there is not much difference. You will hardly understand the difference. It's the same thing you do. So what I would suggest to you is start with YouTube. YouTube is sufficient for you to learn. You don't need a Udemy subscription or a Coursera. YouTube is sufficient. So for a student, start with the basics. Understand what is the industry needs. So as of today, if you want to stand out even in cloud computing, as a fresher, if you say that you have a certification and you know what PaaS is and you have developed applications, then you will have great value. And you might have to struggle a bit to find land a job because if you given, I'll tell you from my experience. Sorry if anyone is from placement cell, Infosys or your, I was in Infosys, so I can say you tell you without any doubt. They won't ask you any technical questions. They will just have an interview which is very basic. And even if you have lots of skills, because I had few certifications and skills, I told them that I have these skills. I had Java skills, but then what you get trained in is not up to you. I got trained in .NET. So for me, I had knowledge of Java, but then I became a .NET professional now, totally into Microsoft technology. So now if you want to control your career, you stick to a programming language and then you choose a cloud, whether you want to go with Azure, AWS, or GCP. Make that decision. After that, do certain projects on that. When I say projects, just create a GitHub account, create a few basic projects. Let's say create a website, host it. Now, then start exploring database part of it. Let's say you have a website, and then you say my website can calculate sum of two numbers. Even that is okay. My website can take an image and give the sentiment of that. So there are many APIs, public APIs, which you can use and find the sentiment whether you are happy or not. Start creating small projects. First is select your programming language, select your cloud service provider. You are good to go with that. And then what remains is try to get an Azure subscription or an AWS subscription. For students, you do get trial subscriptions easily. There are student tiers which you can use and come up with a GitHub repository. Because if I'm taking your interview, you will say that you know this, you know that, but there's nothing for you to show that, right? To showcase that, you will have a Git repository and you will host your website in cloud and you can share that email address in your resume, which I'll know that, okay, this guy understands what he's talking about. So that is how you should start with it. Basic for a student is to choose these two things and start with doing projects because that adds the value. Okay, so is it clear or do you need more clarification?
I guess that's fine. Our next question is cloud computing more or less reliable and secure than running my own software in-house?
Okay, so when you say in-house, I'm assuming you are an individual. Okay, even if you have, let's say, a good hacker level skills also, you are still less secure than a cloud service provider. Because imagine this, your cloud service players are not just a startup. It's Microsoft, Amazon, Google. They have years of data, years of intelligence, and Microsoft for their own part had Microsoft Defender, Microsoft Firewall, their own solutions, security solutions. So they have so much vast amount of data. They can track a vulnerability within microseconds, which you can't with your configurations. You can go with the best of the firewalls, best of configurations, but there will be a point which you will miss out. So I can say that cloud service is more reliable, more secure than an on-premises, even for banking clients, which they do not agree directly, but then they have seen instances wherein they have got hacked, whereas their counterparts who are in cloud are more secure. So yes, cloud is secure, more secure.
All right. Our next question is which business systems are best suited to move to cloud computing And where can I find the highest return on investment?
Okay, when you say business system, is there a clarification on that? I need to understand what you want to do with cloud.
Like a type of industry.
Okay, let me let me give you an example. Okay, let's say, all right. Now you consider an example of DBIT. Let's say DBIT is a university. You have student specific website, you have alumni specific website, you have your offerings to the public about the courses, you have the public internet, and then you have certain systems. Let's say now since we are in this pandemic, we are having all the virtual exams, so you need a system to run that. Now DBIT wants to get onto cloud. Now you will approach one of these cloud service providers. That is good, but the problem is, if you approach them directly, you need to have an enterprise agreement. Even if you go for a normal licensing or a normal agreement, it will be very expensive. For a small, small scale client with limited budget, getting a cloud account is very expensive. It comes with a huge cost because again, it's a kind of one-time investment. So if you're a small client, the recommendation would be you would go with cloud service providers. When I say cloud service provider in this context, it's not AWS, GCP, or Azure. It is your Infosys or Deloitte or Accentures of the world, wherein you can go to them and say that I want to go to cloud. Can you help me out? Now, what these biggies have is they have enterprise agreement with Microsoft or AWS. So let's say Deloitte has an enterprise agreement with Microsoft, which is in millions. So they have a 20 million back and forth business. So for us, a subscription, let's say for a normal client, if they are getting a subscription at, let's say, $500 per month, or let's say services $500 per month, for Deloitte, we'll be getting it at $100. So there's a difference of $400. Now, if you go directly to Microsoft, you have to pay 500. Whereas if you come to a Deloitte, DBIT comes to Deloitte and say that, yeah, we need to go to cloud. So what we'll understand your requirements and we'll say that, okay, you need this, you will need this much services, this much, this. So then I'll say $100 for sure will be the base fare. Then you will say that you need to use so much resources. Now let's say that would come up to 80 or $100 a month. So total becomes 200. And then I, as a service provider, Deloitte as a service provider will have their own costing, let's say $80 per month. So total would be 280, which is still profitable. So this is how a small client would go to cloud. They won't go directly to your cloud service provider. So this is one approach for a small or medium-sized client who just want to explore cloud and want to get started. Now comes your big wigs, Netflix, or let's leave Amazon Prime. Let's come to Netflix. So Netflix uses AWS. Yeah, Amazon Prime is competitor, but they use AWS. Now Netflix has got a enterprise agreement with AWS. They get best of everything. They get everything earlier than the public, normal clients. So if you're a huge client, a billion-dollar client, you can go directly. And that is what, there you will have economical benefits because you have an enterprise agreement and you have sufficient money to have your own teams to run things. In case of DBIT, you wouldn't have someone who is adept in cloud to run your systems. So you need to hire a person, which is again extra cost. So you will just go to a Deloitte and they will take care of everything. You just need to give your requirements, done. So that's how a small and medium client works. Whereas a large client, they will have their own IT team who's good at cloud, and they will have a direct relation with your cloud service provider. So that's how you should go. That should you start with and understand what is best for you. Yep.
All right, that was a really great answer. I have another question.
Yep.
Does the cloud platform support multi-tenant operations?
Yes. So multi-tenant, when you say multi-tenant, again, I have to know do you understand what a tenant is? Whoever asked the question, okay, I'll do one thing. I'll try to explain. Now, when you say multi-tenant, let's take the example of Azure. In Azure, when I showed you this website, right? I told you this is my Azure account. So now this entire thing is situated on my tenant. When I say my tenant, let's say it is Rivinjos. Now, if I had another tenant called as Rivinjos DBIT, that would be a separate tenant. So if you, let me show you here. If I click hover over here, you can see, right, the pop-out comes saying that directory Rivinjos and there is a bracket, there's an ID, right? Now that ID is called a tenant ID. Now, let's say DBIT has a tenant that would be different. You will have different directory name, different directory as well. So that becomes a tenant. So yes, you can have a multi-tenant. So in my project, I'm on a multi-tenant environment where I have multiple tenants. It's not just one account, one client. There are multiple clients, and each of them we have given different tenants. So that is one tenant understanding, wherein each and every clients are separated by tenant depending upon the use case. So when you have it, when I say tenant, right, all the users belonging to that tenant will have an email address such as, let's say, rivinjos@rivinjos.com. You will have student@dbit.com on the separate tenant. So that becomes a tenant differentiation. So yes, multi-cloud is very popular. So many clients go with this multi-tenant approach. Now multi-tenant is one, then there is multi-cloud, which is the hybrid cloud, wherein you will have some things in Azure, you will have something in AWS, and these two can be connected. And these cloud service providers, they are huge into collaboration. They don't have this thing that Microsoft and Apple had in the beginning that, okay, we won't share anything that we have. No, these guys are quite open to collaboration, wherein you can run an app service over here and you can store the backend in AWS. So that is another type of multi-cloud. Whereas multi-tenant in traditional terms is what I said earlier. You can create different tenants. So when I say tenant, it's the word tenancy. So you have a tenancy in one tenant. So that's how it works. Yes, it's supported.
All right, thank you for that answer. This is the last question we have. Is it safe to store data on cloud, especially in the age of hybrid warfare?
Okay, let me ask you a question. Is it safe storing data on your system if it's connected to internet?
I don't think so. I mean, if
It
it's
is not.
connected to the internet.
Yeah, it is not. So see, I will say that security SLA, again, I won't say they will give you 100%. They will give you 99.999%. I'll tell you why. Now, it is as secure as you make it secure. So I told you, right, they give huge amount of security. Now, this is something called a security center in Azure. I'll come to that, but I'm just opening it. So they will give you all kinds of security. Now, it depends on your architects, your designers to implement that properly. So what I meant to say is that now I've created this VM, right, that I remoted into. I use the public IP. Now you have that public IP. You can remote into my machine if you somehow find my IP address. So that was because I didn't put a firewall. So that security problem is because of me. The while creating the public IP, creating the VM, it said that you are under possible risk because you are exposing an IP address. So cloud is taking care of its end, but we didn't do our due diligence. So what happens is it is as secure as you can keep it. So we have done configurations wherein for the entire subscription, there will be, let's say, hundreds or thousands of VMs and services running, but there'll be only one IP address. So there's only one IP address. So what we call it as a surface of attack. So if you have multiple IP addresses, your surface of attacks increases. Whereas if you have one IP address, you're limiting that. And that one IP address you can further protect by using IP filtering. Then you can have policies to prevent DDoS attacks. So that's it can get as secure as possible depending upon your skills and your understanding. I'll tell you the reason why, because a few years back, what used to happen is people used to just create VMs and app services. And then I told you, right, you can have GitHub to host your code. So people were hosting their code and they had configurations all exposed. So GitHub, mostly people keep it publicly exposed. So these, I would say, hackers or Bitcoin miners, right, they keep on trolling the internet for IP addresses and VM addresses. So once they get it right, what they do is they brute force into the VM. So they need processing power, right, to perform Bitcoin mining. So what they used to do is they find the public IP addresses that is floating in the internet, and then they use brute force and they log into the VMs and then they start Bitcoin mining because it's free processing. So that was one problem. So yes, these are the vulnerabilities that happens usually, but all this can be mitigated to, I could say, 99.9999% if you implement proper security. So yes, I would support this security over anything else we have, because I've encountered these things happening in my projects as well, wherein even if there's one IP address that is exposed without any rules, right, this thing will start giving me reports. And this is the first level. There are next levels of AI based intelligence wherein they will constantly keep track of everything is running on your subscriptions, and then they will say that even before an attack happens, they can say that this would probably cause an issue down the line. So that's how secure cloud is. So This reluctance was there years back when people were like, "Arey, I don't know where the data is," but it's secure, more secure than you can do it yourself.
All right. Thank you for that answer. I have a personal question.
Mhm,
So, suppose if I would like a job in a tech company, on
mhm.
a software company, how does having knowledge of cloud or like a certification in cloud help you to secure that job? Like, how does it compare to other technologies that
Yep.
you know?
Because cloud is the you can say a few years back when we were starting, there were all the web technologies going on, or database technology, wherein if you know uh, a good web technology or UI technology like Angular JS, PHP, or any full stack, it was the in-demand skill. Now the thing is, all those have become secondary because anyone can now create a website. Okay, because everyone is getting trained at such a level that you all know to code to do things. But what differentiates you is your cloud skills, wherein you should create application that is optimized for cloud. So this will come with your experience. When I say optimized, if you're hosting something in cloud, you wouldn't want to upload everything you have at your local. Let's say you have a video of 10 GB and you upload it along with your code. It is foolishness. You shouldn't do that, because if it goes to this app service that we created, right, where our website is hosted, it is more expensive. So if you have cloud training or cloud knowledge, you would know that your bulk files will go into something called as a storage account, which is very cheap. You might have heard the words such as blob storage, page storage, right? So those are technically used for storage purposes. So if you are trained on cloud, your value increases because everyone wants to get onto cloud. Now, if you have followed the news, Microsoft backed a huge multi-billion-dollar project from US government for cloud implementation. Now, what happens is Microsoft is not going to do everything by themselves. They will now outsource this to other companies like Deloitte, Accenture, etc. So they need people who understand cloud readily. These companies want to reduce the training time. They can train people, but then if you are going there saying that I have the skills and experience, they will hire you, and you have an edge. Believe me, you have an edge, because I have colleagues who have chosen not to go with their campus recruitment. They joined a startup or a small firm, which we might feel like, okay, Arey, this is a step down or a risk. It is a certain risk, but then the amount of things you get to learn there is different, because you might not be as lucky as me to learn things in an Infosys or an Accenture. You might spend your time in a stupid project, testing project, doing nothing worthwhile. So let's say you are there and there's another guy who's got cloud skills and you both appear for the same interview, he will get the edge. So even as a fresher or a college student, you can start preparing now and then start giving interviews if you have cloud knowledge. It's very much in demand. And I think Deloitte is now on a hiring spree. I used to take interview every day. Similarly, I think they are going for BTA hiring as well. So you guys can search for those fresher hiring. So if you are interested, you can try those. So definitely there is too much demand. So even if you write, Azure or AWS, right, you will start getting calls from these consultancies or HRs. So yeah.
All right.
So you need to have the skills. So again, as I mentioned earlier for the first question, make sure that you choose your programming language, you choose your stack, choose your cloud technology that you want to go into, whether it's AWS or Azure, and then you can start learning. It's enough. That's good to get started to have a career.
All right. I think that's it for our Q&A round.
Yep.
Thank you, Mr. Riven, for answering all our questions. I think this has been a really comprehensive webinar, because not only did we get theoretical knowledge, but also we got a live demo. And this was kind of like a workshop itself. So I'd like to thank you for that demo. And now I'd like to invite Chriselle to propose the vote of thanks.
Thank you, Mr. Riven, for speaking to us. We are grateful for your time and effort you took to give us a better understanding on cloud. I'm very sure all our students must have benefited from this webinar. It was definitely an amazing experience, and to see the live demonstration was great, and including all your relatable examples. It gave us a better perspective. I would also like to extend my gratitude to the entire alumni team, the volunteers, and all the teachers for supporting and organizing this webinar. Thank you everyone for being a part of this webinar, and I hope to see all of you in our future events. A feedback form is already circulated, Please do fill it and let us know your feedback. Goodbye and have a good day.
Thanks, guys. Thanks for attending this. Have a great day.